Solve another Leetcode problem, 377, combination sum 4. So we are giving an array of distinct integer nums and a target value. For example, this is 4, and the nums is 1, 2, 3. And we need to return the number of possible combinations that add up to target. Yeah, so for this example, we can have 1, 1, 1, 1, that is one case. And let's check this case. This is a little bit special. So 1, 1, 2, 1, 2, 1, and 2, 1, 1. So there's three cases like that. So it means that there is a sequence. If we take the first number as 1 and the second number as 1, 1, 1, 2, so that is different from the first number 1, 2, and then go back to 1. Yeah, so this means this is an unbounded knapsack problem, but also with a sequence. Yeah, if without sequence we will get wrong. Now let me just copy the template to solve it. I want to copy the 0, 1 knapsack, and then I'm gonna change it. Yeah, let me find a similar template. Maybe the target sum, because the target sum is the 0, 1 knapsack problem. Yeah, let me just copy the 0, 1 knapsack and try to explain it. Yeah, now I'm gonna change it to unbounded knapsack. Yeah, so this T is the target, the starting point. So this is the target value. So this T gonna equal to the target if we're gonna return a 1, otherwise a 0. So this is just the counter, the boundary case. Yeah, because this is a 0, 1 knapsack, we can use this kind of I equal to length of nums to check the result. Yeah, but our problem is unbounded. So how can we solve the unbounded? Yeah, we can change it like this, maybe from here. So for this problem, we don't need to minus the value. So this T with I plus 1, this means if we did not choose this number, for example, for the first number, if we decided not to choose the first number, it's gonna be I plus 1 directly. Otherwise, if we decided to choose this number, so T would plus this nums I, and here would be I, because this is unbounded. If we decided to choose it for this time, so next time we can still choose it. Yeah, but this way we have a sequence. So if it is a 0, 1 knapsack, we always have if it is a 0, 1 knapsack and also without sequence, we can do it like that. But here is unbounded and with sequence. So for this way, I've already changed it to the unbounded knapsack, but here I need to change a little bit. And let me first change this T. So if T is more than the target value, so what are we gonna do? So I need to return a 0 because I didn't find it. Yeah. So if T equal to the target, it means I've already found a value, so I'm gonna return a 1. Yeah. So if I equal to the length of nums, I'm gonna return a 0. Yeah. So it will be like that. So in this way, there will be a sequence. Yeah. Let me just run it to check. As you can see, the case 1, there is only 4 result, but the actual result is 7. Why? Because we have a sequence like 1, 1, 1, 1, and for this one, the second one, it will be 1, 1, 2. But we don't have 1 to 1 because we can never go back. Yeah, you can see that. For 1, we can choose many times, but we can never go back. While we are choosing 2, we can never go back to this 1 again. But here, this is 1 to 1. This means our solution is not right. Yeah, because there can be a sequence, because 1, 1, 2, 1, 2, 1, and 2, 1, 1, it's the same. So this is 1, and these are the 2, and 1, 3 are 4. Let me check. This is a 1, this is a 2, it's the same, 3. Yeah, and this is the same, this is the same, and 2, 2, there are only 4, because we need to delete this 2 and also delete 3, 1, because if we have 1, 3, we can never have 3, 1 according to our algorithm, because for our algorithm there is a sequence. We're gonna choose 1 first and then 2 and 3. Yeah, but our algorithm does not have that property. There's no such sequence. Yeah, but actually our result have a sequence like 1 1 2 1 2 1. Yeah, if we can, for the first time, we can choose 1 or we can choose 2, it doesn't matter. Yeah, it means we need to change our algorithm, yeah, to correct it. But how can we do that? So in order to change the result, actually, for each of the DFS, we can choose any kind of numbers, as many as possible. For example, we can choose the number 1, or we can first choose the number 2. So like this way, we have a sequence. So for example, if we first choose the number 3, next time, we can also choose the number 3. If it is more than 4, like 3 plus 3 more than 4, so we're gonna return a 0. If it is equal to the target, we're gonna return a 1. Yeah. So we don't need to check the length of the nums because we're gonna choose any numbers. So I gonna delete another 0 and delete this I because I don't need to have the index. Because for this index, it just means there is a sequence like index 0, 1, 2. Now I don't need to have the index. Yeah. So it means these areas I need to change it. Yeah. Basically, I need a sum. So f, the DFS, f would be fn. So for n in nums. Yeah, let me check. So yeah, I think it should be, yeah, ft plus n for n in nums. It would be like this. From the beginning, this t, the target is 0. Now for each of the time, I can choose a different result. I can choose t plus n. Maybe I can choose t plus 1. It is f1, f2, and f3. And then I will execute the DFS like f1, f2, and f3. For f1, maybe I can find f1, 1, 1, 1, f1, 2, 1, or f1, 2, 1, 1, 2, 1, 2, 1, or 1, 3. And for this f2, I can find 2, 1, 1, 2, 2. And for this f3, I can find 3, 1. So in this case, we will combine all the sequence. And for each of them, there is a sequence for the result. But for the numbers why we are choosing, there's no sequence like 0, 1, 2 for the index. So it can be any numbers for the first time and the second time. Yeah. So this is why we call it unbounded knapsack problem with a sequence for the result. Yeah, because the result like 1, 1, 2, 1, 2, 1 has a sequence. Yeah. Now let me run it to check. As you can see, it works. Now let me submit it. Yeah, as you can see, it's pretty fast and it passed all the testing cases. Yeah, and for this problem especially, you just need to consider there's a sequence. How can you make the sequence for the knapsack? So you're gonna enumerate all of them for each of the time, and only in this way you can find all the different combinations. Thank you for watching.